All right, welcome everyone, and thank you for coming. I'm really happy to see that we got a full meetup again today, and yeah, welcome to one more workshop. Today we're going to talk about dependency injection, but first I would like to tell you what Lambda 1 is, which is our community. In Lambda 1, we believe in empowering the programmers, the mathematicians, and the system designers. Because in a world with extraordinarily complex and critical problems, we have the best tools to change our world for better. And that's why we are giving trainings, we're creating a network, and building some tools. If you're interested actually in what else we're doing, you can talk with me later. But also reminding everyone that we have the responsibility to use our powers in favor of our society. And I really think that us developers, mathematicians, system designers, we truly have big powers and we should use them actively. But anyway, I like to start workshops by telling people that we programmers are like philosophers, because we try to discover the abstract structures of nature, except that we do it to express them in code. So please do think as much as possible, share your thoughts. There is no criticism. It is not an intellect race. There is no ego, only curiosity and delight for the abstract. So we're gonna implement a technique called the Feynman technique. So we will write down our thoughts because it forces us to reason, and reasoning is a path to enlightenment. So I will insist that writing down is extremely useful and we will get a lot of good things from it. So, part 1. Why dependency injection? So let us start by actually reasoning and thinking. So we're going to take 1 minute and please write down whatever you think the answer to this question is. What is dependency and what does it mean to inject it? So it's actually 2 questions, but yeah. Meanwhile you type, I need to apologize because probably I'm not going to memorize your names until the 3rd time you tell it to me, but I'm going to keep asking. Yeah, really bad at that. But I do want to memorize everyone's name, so yeah. All right. I see some people are done. Does anyone want to volunteer?
I can try.
Sure.
Nobody will beat me, I hope. So the first question, what is dependency? It's external component with isolated logic.
Okay.
And what does it mean to inject? It means to embed it into existing infrastructure, to use its open API to interact with it.
All right. Okay, good. So let's do 2 more. Okay.
Yeah, dependency means it is dependent on initialization of other components in a very simple layman terms. And inject means like insertion. That means I'm inserting something, initialization. Before I initialize the main component, I pre-initialize some other component.
Okay. So, all right. And a 3rd one. All right.
Mine is way simpler. Dependency is a construct or a resource which is needed for the dependee to be able to complete its function.
Okay, good. So what I'm getting from you guys, there's first a notion of modularization and interaction with that thing through an API, and there is a certain, well, dependency, right? There is a requirement. All right, so let's go. This is my personal input. I would, in a more philosophical way, try to explain it this way. First, as structure. So first, a structural requirement, which is an object which existence requires an underlying structure, right? Structure, we could define it as objects and relationship between these objects. And that is a structure, right? And then context of existence. So an object is able to exist under certain context, or in other words, an object instance depends on its context and its relationship with such context, right? So what I'm trying to express here is that there is something that can only exist given certain underlying structure, right? Or certain context. And its existence is defined by this context. So, does anyone want to add something? Because actually the next part is, given the things that we shared, do you want to say something?
No, maybe environment is a better word for it.
Environment is a nice word, right? Environment is a type of context, right? So yeah, I agree. So given what we just shared, please take some time to maybe write down what you think after what we exposed. Did it change? Or, yeah, you can refine it.
Can you go back to what you said?
Yeah, sure.
It always implies a hierarchy kind, so something that must be available before something else is. I'm able to construct something else that must be available before I'm able to construct the next step. So kind of a.
Well, that is a really good comment, right? Because it does takes us to the concept of hierarchy, and in the end, what we have is a multiple and transitive dependencies, right?
Yeah. Three.
So yeah, this underlying structure starts popping out as a concept of a graph, right?
Yeah.
So this is what we see maybe when we want to, get our packages of our software, and there can be, transitive dependencies, which are more than one step. Like if I depend on something and that thing depends on another thing, then I depend on that thing as well, right? So it's probably has a transitive property, right?
Yeah.
So in mathematics, there is the property of transitivity, right? So does someone want to explain what transitivity is, or knows what transitivity is?
Yeah, in a relationship you have A related to B, B related to C implies that A is related to C.
Yeah. This concept of transitivity is really, really deep. You find it everywhere in mathematics and also in programming. Actually, I would insist that it is really important to understand sometimes mathematics to get like really good insights in programming. Actually, there's a really old proof that proves a correspondence between mathematical logic and proofs to programs. So, does anyone want to share how your thoughts got refined by this? Or maybe you do not agree with something. Not agreeing is perfectly fine.
So I was thinking the dependency is it one way or two ways or more ways. So the quality of
That's actually also interesting, right? Because then our definitions lead us to the possibility of circular dependency, which is probably what you're reaching at, right? Because if it's two ways, then there's a circular dependency, right?
So I mean, object is dependent on its context.
Yeah.
Could it the other way around too? Actually, that's the case.
It could be, right, because
In nature,
what if
it's
the
the case.
context of something is the other thing, like each other are the context of each other, right? Then that leads us to the concept of a circular dependency.
So, yeah.
Sorry?
The log, yeah.
So so an object can have the role of a context.
Yes. So actually, this is why we're starting like really, really abstract, right? Really philosophical, because when you start abstract, you start finding the properties of this abstract thing, right? Like, for example, the possibility of transitive dependencies or the possibility of circular dependencies, right? And then as soon as we find something more concrete that fits this abstract model, then automatically we gain for free all of this knowledge that we already got from its surrounding, right? So, for example, you say, an object can fits the model of dependency, right? Objects can depend on each other, blah, blah, blah. And you already for free gain all this knowledge, surrounding knowledge, right? Like, for example, you could say that objects have transitive relationships between them, right? So if object A is related to B and B to C, therefore we could say that A is related to C.
I have one question. You told about context, and then the object, but it was something about structure. The objects exist in some context, and then context, how to say, not shows, but compose the object itself.
Yeah. Actually,
So
composition.
it lives in some context, but it can live only in this context.
Yeah.
Right? And what does it mean? This is like some how to say, restriction, right? Because
Yeah.
it cannot live in another context.
Yeah, so that is a really good one, and I like the fact that you use composition, because composition is gonna be something key here, right? And then what we're gonna see is that this context does put certain restriction on the existence of the thing, but this restriction might be a little bit flexible in the sense that several things might fit this restriction, right? And this is where we're gonna probably reach your concept of modularity. So, let's go to the next step. Well, and I wanted to like also add that injection is the action of providing such context, right? So to instantiate the object itself. So, let's go to the next question. Why will we need dependency injection in our programs? So let's take 1 minute to write it down. So let's go for someone new. Dennis, probably I've seen you're in deep thought, so probably you have something good.
Okay, first, I don't think that we need dependency injection by itself.
Okay.
But in general, how it can help? First, it makes your code base just shorter. Second, it makes it more flexible, so you can compose your objects whatever you wanna in a more flexible way.
Mhm.
And probably that's it. Like composition became easier, and code base became smaller.
Yeah.
I can argue
Good.
with you here. Basically, yeah, let's.
Good,
but
good.
I'm not gonna jump on it, but basically, you need dependency injection because you have different units,
Mhm.
and each unit have its own single responsibility principle,
Yeah.
and you want somehow basically you can think of the unit as a function. Each function has input. That input you can think of it as a dependency injection.
You're talking about dependencies, not about dependency injection. Like inversion of control is
No.
probably the same.
Yeah,
Like you can
correct.
have dependency, and it can be no dependency injection at the same time. So if you're getting something as parameter constructor, it's not dependency injection.
I think what he's trying to say is, correct me if I'm wrong, like what he's trying to say here is that you can do a unit test of each of the component independently. That means, like, if I want to like run my component,
Sure.
yeah, I can do that with dependency injection principles.
You're right, but
Right.
I was thinking that I told about it. Like it provides flexibility to code. You can mix your components in a different way with each other. But yeah.
Okay, but actually, so that's a good one. What is the difference between the general concept of dependency and specifically dependent injection?
So dependency injection is an object-oriented term. Basically, you have classes. You want to somehow slip in some object that behaves as same as what you want somehow to behave. So that's the object-oriented way. But in functional programming, basically you don't have that, but somehow you have that for functions. You have different functions, and basically each function is receiving an input, and somehow this is same behavior as we want in object-oriented programming.
That is good. So actually, what I want to maybe achieve is break a little bit. Maybe, for example, when you say dependency injection is something proper from object-oriented, and say not necessarily, right? We could conceptualize, we could create the concept of dependency injection as something more general, and see how it applies in something like object-oriented, or how it applies in functional programming. And actually, in the end, I would like to say how maybe dependency injection in object-oriented might be an instance or something more specific to a more general world, which is functional programming, right? But let's go. Let's have someone else answering this question. So, sorry, what was your name? Michel.
Yes.
So, what did you wrote down?
About injection.
Yeah. Why do we need dependency injection in our programs? Or is a good idea?
One thing I'm doubting, the other thing is automatic instantiation.
Okay.
So essentially, your components are usually taken care of by the system which instantiates them, and that's the whole idea. That's usually the white candy, and the implementations are sort of pluggable.
Yeah.
You can have different implementations with the same API contract, whatever you
Yeah.
call it.
So we keep going back to the concept of modularity, right?
Yeah. So that's why practically we need it, or not practically, just in general, why we need it.
Well, be useful, yeah.
Yeah.
So I would like to give my input, and what I thought is that what we want is to modularize our programs by parameterizing them, right? So we actually module is then again an important word. Or in other words, we want to be able to adapt the behavior of independent parts by injecting context, right? So personally, I think these are the words which are important, is adapt the behavior of an independent part by injecting context, right? This is probably what we do in object-oriented. we say, hey, so okay, what is one good example of dependency injection is like we have some business logic and we want to inject a service, right? So the business logic is ignorant about how to access a service, but we inject something that knows how to access a service, right? So we can adapt the same business logic to interact with either or mock-up service or with a service in HTTP API or something else, right?
So it looks like we give a life of something not dead but logically like tool. It's by itself it's functional, but it doesn't breathe. So you just inject some context, some life, and it start to have some idea of what it should do, right? Yeah, because for example, if you have your business logic, right, within the business logic, there is this strong requirement of being able to communicate with some service. So without any service, then the business logic simply does not exist, right? You do need to put that part, right? And then we could go a little bit maybe more philosophical and say, like, for example, what are the minimum requirements for something to be a human, right? What is this, is like really thin line that if you cross it, like if you add like an arm or a hair or something, then it's already considered a human, right? This is what we call an ontology. So it's composition of concepts. What concepts are related to each other, and they also depend on each other, right? You can imagine a big graph of concepts, and so for example, multiplication, it is a composition of other sub-concepts, and there is a minimum amount of relations required for something to be considered multiplication, right? So let's write down, if you got any thoughts refined, if you would rewrite what you wrote in the beginning, yeah, please do.
I don't think it's about adapting. I don't agree with that.
Okay, good. Mm-hmm.
Dependency injection in general, I think it's mostly about, apart from testing, it's for testing, it's adding modularity to code is to make it more manageable. Like 99% of the times, you don't have to adapt or to choose. You only have one way to compose things.
Yep.
But you decouple them, you make them smaller, you make them more manageable, and you make them more simple to analyze,
So
to see them in a smaller context.
So probably we go back,
Dependencies.
we actually probably go back to the concept of a module,
Yes.
right? A modularization.
Because
So-
rarely you have like the typical example with interface with implementations, or I don't know, the same function, the same two instances of the same type class.
Yeah.
99% of the times that doesn't happen. It happens only mostly for testing because you mock stuff up, but that's part of the program being modular.
Yeah.
I think.
So maybe we could change a little bit and say that dependency injection allows for either adaptation and modularization, right?
Both of them.
Yeah.
It's like your input remains the same. If you want to extend any features, if you extend any functionality, okay, for any existing requirements or any more requirements, the input remains the same. You can extend your requirements.
Yeah.
Okay, by dependency injection, your input doesn't change.
Yeah. Yeah, indeed. And I like that you use the word input.
Yeah.
Does anyone want to add something?
Can I get a clarification? Because basically what we're saying, you're not necessarily depending on something, but more on the behavior of something. Because
Context.
yeah, okay. So maybe it's my lack of knowledge about the terminology. But coming back to transient dependencies, how can you say that A depends on C if it depends on B, if A doesn't even know about C and the behavior exhibited by the dependency of B doesn't have anything to do with C itself, because C can be just about anything.
If you only have one B, then it's true that if B can do anything, it will not dependency, and then it's not implied.
Probably. So that is a really good comment, right? Because when we talk about modules, we also need to talk about the interface and the instantiation, right? And you can have dependencies on both sides, right? Like a type class. A type class can have a strong dependency, right? Like a monad strongly depends on an applicative and a functor, right? Or a monoid in a semi group, which gives you certain philosophical input, because you might think as a monoid requiring a semi group, or a monoid is an extension or it extends the structure, of.
It's a restriction because it has more properties.
Yes, exactly. So it's more general.
I see it more as an application. So a monoid implies a semigroup. So if I have a monoid, I always have a semigroup.
But
if I have a monad, I always have a functor.
Yes, indeed. But then there is an underlying structure, right? If I give you a monoid and then I tell you this monoid doesn't imply a semigroup, you can instantly conclude that therefore that is not really a monoid, right?
Yeah, it's a contradiction.
Yeah. So it is this dependency is actually creating a really solid structure which you cannot escape, right? As soon as you have a monoid, you cannot remove the concept of a semigroup.
I think that's a bit different because here we're talking about like properties on structures.
So we are talking about inheritance here and dependency injection. It's somehow different.
If we're talking about modules, the module can use generally speaking, an abstract module, some unit of work can depend on some other unit of work because it does something and it needs what something else does. But in the case of mathematical concepts that map to whatever type classes or anything, it's the opposite. It's just having properties and adding more properties plus restricting the context. So, for example, a monoid is a semigroup is more generic than a monoid because a monoid has more properties, and they do not depend on each other. It's just that one is the same thing as the other with one more property that makes it smaller.
Yeah, but for example,
so
I will
more strict.
I would.
I think it's a bit different.
I would argue that it is not different. That our world of mathematical properties actually extend all the way to maybe like object-oriented or stuff like that. Like, for example, object relationships.
Let me add just one thing. I think a monoid, since we have this example, or a monoid is not, doesn't depend on a semigroup. A monoid is a semigroup.
Yeah. Yes, exactly.
It's not dependency. They are the same thing.
Exactly. But this is what I wanted to go like back then when I said like there's a structural requirement. Like there is a structure behind, right? And so what I wanted to say with okay, I'm lost in the slides, but what I wanted to say with requirement on the interface side and on the instance side, right? If it's on the instance side, which is the other thing that we could talk about, right? That's when transitive dependencies become transparent, right? Like they're not necessarily true, right? Like if I depend on A, but depend well instantiated, so if my instance depends on that instance, it only becomes a rigid structure when you instantiate all the parts of a structure, right? So probably it is a nice conceptual differentiation that we can do between a dependency on the interface, which actually makes a rigid structure. It expands properties, right? It is more general it becomes more general, and then on the instantiation, which might be swappable, right? But good discussion. So, let's go to the next one. What method, tools, or techniques do we have in programming to achieve dependency injection?
Too many.
A lot, yeah.
Most of them really bad.
Then let's make another question. What do they have in common?
Interface.
Interface.
Oh yeah, interface, that's a good one.
Abstract.
Basically, you have to pass the
Restrictions.
context.
Yeah.
Restriction, interface restriction.
Abstracting what they do from how they do it, I guess.
So then again, we fall back to this. We always have the interface and the instantiation, right? Interface and instance. So we are already reaching some really general properties of our abstract being of dependency, right? The world of dependencies, there's always certain notion of interface and certain notion of instantiation, right? Or application. So that is good. So given that conclusion, actually, I would like to say, hey, let's go to the very essence of dependency injection. And I would argue that the essence of dependency injection, it is a function object, right? So first you have the interface or the declaration of the structure, right? Which is the function itself. And then you have the injection part, which is function application. Okay, and we're actually gonna see that in a moment. Any questions here?
Let's see the example.
These are not tools. Like the question was, what are the tools and techniques?
Yeah, that is a good comment. What I wanted to reach was what is common between all of them, right? So this is the most important thing, right? Because when we want to, maybe you'll use some Spring or what was this Google dependency injection thingy? Juice, yeah. And then you get used to it, right? No pun intended. And then and after 2 years of developing those applications, you move to a whole different world with their own dependency injection. But this time it might be like way faster to understand it, right? Because you already know the basic properties of what dependency injection means. You just look for them and then you're like, okay, yeah, I already understand everything. But even better, when you go to functional programming, which is the world where everything is, we directly use fundamentals, then there is only a few ways of doing it, right? You don't need any fancy tool like Juice or some meta programming. No, you already have the essentials, right? You just need to apply them. That is the thing I want to reach, right? So, given what we just discussed, another 30 seconds to maybe write down your own conclusion on this.
Each time we just abstract and abstract and abstract, make it more applicable for everything.
Yes.
Okay.
Actually, normally the way in which I will compare this to the way in which sometimes mathematics work versus natural sciences. Natural sciences start top down, right? They don't know anything about things. They just start experimenting and popping things around, making experiments, and then trying to realize truths about it until they reach a model, right? An abstract model. And mathematics sometimes start the other way around. They start with very basic things, very basic axioms, and they start discovering properties on top of it until they reach a model which they don't know if it matches something within nature. But suddenly one day someone says, hey, this model actually fits nature perfectly, right? So us programmers, what we can do is be a little bit more like mathematicians and before trying to go to something within nature, like, you know, or tools for dependency injection, whatever, what if we try first bottom top, right? By being very, very abstract and trying to realize what are the structures behind it. And then we start finding the structures, and we start, you know, building our way up until we have something that perfectly describes all of this, and we're able to master anything, right?
Bottom up.
Bottom up, indeed. So anyone want to share your maybe refinement of your thoughts?
Can you show the previous slide with this formula stuff?
This one?
I think it's a little bit different, but when you describe the dependency, you indeed have this A to B thing. But when we talk about tools and techniques, what actually is implied is that when you have a dependency, so you have this solution of this A to B, and you have you have this thing, and the tool is supposed to find you such an A that the dependency is satisfied.
Yeah.
And that's the whole point of automating this.
Yeah.
That's why it's injection. That's not just because otherwise it would be just a passing a parameter to a function.
So what you're talking about is automatic wiring, right?
Yeah.
So
well, wiring. Yes. So the idea is that there will be some tool which finds a suitable A for you, so that this dependency is satisfied.
Yeah.
Otherwise, it wouldn't make much sense. Otherwise, it's just a passing a parameter to a function, and that's it.
Passing a parameter to a function is dependency injection. It's just that you're doing it manually instead of
Yeah.
like
Yeah, but that's why.
But then you don't make it a special word for it, right?
So that's why I'm confused why the function needs to be there, because it's about injecting something. Why does it have to be a function that is injected? Or am I not reading this right?
So this is good discussion, because, for example, I would agree with Giovanni, right? Yeah. So with Giovanni, in the sense that we need to make a separation between dependency injection as the whole mechanism and the extra tool of just automating over it, right? Of finding a suitable spot for it. And then my extra input will be, we even fundamentally have tools for that. In functional programming, what we normally do is let the compiler do it for us. And this is when we're gonna reach in the next slides the concept of, for example, type classes or implicits in Scala can become more automatic wiring. But I would argue that automatic wiring is not something that is strongly proper of dependency injection. Like, you can do manual dependency injection, right? And it doesn't have to be bad. But the important thing is, I will say that the most important thing are modules, behavior, and the composition of all of this. If you have a nice tool to automatically wire it for you, well, nice, right? But that is probably not the most important thing.
Yeah, I just try to revise and make it more abstract. The next level.
Good, good.
Yeah, so that I have some sentence method to allow object A to be extended with properties and behavior of object B.
Ah, nice. So you're introducing a certain notion of inheritance.
Yeah, it was like, I didn't like it to use the word extend, but it's really like, I thought about unlock. So the object B is unlocked with something extra, and which is pluggable. So you can unlock with this direction or with this, doesn't matter if you just unlock it with different behaviors you can plug in.
I think this makes a really natural transition to my next slide. Actually, thank you for that. So, are there types of dependency injection? Are there different things you can inject or depend on?
Yeah, it depends on how abstract you are.
Yeah.
Yeah,
I guess this is a bit general.
That's the big problem I'm having. Like, we're jumping between multiple layers of abstraction sometimes in the same sentence. Well, for example, your very first slide was talking about structure, almost data structure-like, and then the next slide went to something that implied behavior of a dependency.
Yeah.
I'll just watch for a while, I guess.
No. But it is good. It is good. You know, I'm making this completely on purpose because it is funny, but the human mind is really the way in which it trains is like machine learning. Like you just classify and say yes, no until you become better at it.
It's neural network.
Yeah,
Actually.
literal. Yeah, literally.
Literally.
Yeah. So what I want to do is like thinking abstractly is also something that I think you can train, right? So if we constantly try to think abstractly, it becomes so natural that as soon as you get a new problem, you can automatically, figure out things really fast, and this becomes extremely useful. This is the thing that you really get used from mathematics, right? That it allows you to think abstractly, but with structure. You don't lose yourself into. This is probably the difference between us and philosophers, which is philosophers, they can really lose themselves into all of these abstractions. But in mathematics, we still keep our feet grounded, and because we use a formal method of proving things, right? We can actually prove things and constructively go into more complex truths. But thinking very abstract, even if it's in a moment like a little bit hard and stuff, you get better at it, and it's good. I would say it is good. So my personal answer, yeah?
Well, I have an association, so I try to answer this question.
Okay, good.
So I'm thinking of generalizing.
Okay.
Could that be a type of dependency injection?
Generalization.
Yes, as a phenomenon.
Well, actually, I would say probably generalization is the process of designing your dependencies, right? Because before actually creating dependencies, you need to know what depends on what, right? You need to think about structure first, right? So when we talked about, like, for example, monoids and semigroup. So for those who are not familiar with monoids and semigroup, it's actually something extremely simple. A semigroup is just one operation like addition or multiplication, which it has basically two arguments. We call it binary. And it has the special property, two properties, which is that this operation is closed. So that means that it takes two integers and returns another integer. So it's always within the same type. And it is associative. This means that A plus B and then plus C, it should be the same that doing first B plus C and then adding the other one, right? Like integers. Integers under addition makes a semigroup. Monoid is the same structure, the exactly same structure, plus the extra property that there is a special object between all of those objects, which we call the zero element, zero element. So it works like the zero in addition, right?
Zero.
So if you take any element with the operation and the zero element, you get the same element in the beginning, right? So it does nothing, basically. So, yeah. So a lot of things make monoids and a lot of things make semigroups. Actually, an incredible amount of things. Everything in the end is a monoid, and it's so annoying. And at the same time, really cool, right? Because you already know a lot of things about monoids. So yeah, you need to go through the process of generalization, because then through generalizing things, you identify these structures, right? And you can slide them, right? Slice them. And then my input to this one is yes and no. First, yes, because I will maybe in the beginning make two distinctions. One is object dependency, so objects that we require in order to do our computation. And the second one is functionality dependency, which are things that we need to be able to do in order to do our computation. So
what's the difference between an object and thing? Sorry. What's the difference between objects and things in this case? Because if they're the same, it will be the same two things.
Yeah, probably I should have changed things for objects. That's my mistake.
They will be the same.
Yeah, so an object is the thing that is the most general. It's the thing that describes everything, right? So it's everything. Everything is an object, right? So in mathematics, when we say an object, we literally are describing the universe,
So
right?
even a relationship is an object.
Yeah. Yes.
Yeah. Okay.
Even a relationship is an object, right? So what I want to say here, for example, is that object dependency means something like configuration, right? In order for maybe a piece of code to work, we need to first provide certain configuration, and then our computation will work accordingly. And with functionality dependency, we mean something like when we inject a service, right?
Yeah.
Logic. We insert a logic when we use type classes.
Why don't you say, okay, you mean functional dependency? By functional dependency, you mean actually a kind of process, and object dependency you associate with a thing.
Yes.
With an object, right?
Yeah.
Instead of objects, values, something static.
Yes, exactly. Something, it can be values, right?
And the other one is changeable.
Yeah, and the other one, it produces values, right?
One has a behavior, the other one doesn't have a behavior.
Yeah.
That's the difference.
Yeah, exactly.
I don't get the difference.
Exactly.
The one is a process, the
Now,
other one is not.
it is also interesting because you in the end, and that's the part in which I know, shouldn't actually find a difference, because what we study in functional programming and category theory is that function or functionality are also objects, right? We study functions as data, and data could be functions, right? So, which that gives us a really good, a deeper truth, which says we could actually interchangeably use our dependency injection styles, right? But
So
let's finish.
So in the end, a process is even an object.
Yes, exactly. This is one of the main things in functional programming. Even processes can be objects, right? Yeah. But anyway, this was a part in which we, just discuss and, fight with each other and say, no, things are not like that. But it was a first good moment to just make ourselves think. And now that we are reaching certain, key concepts, I will jump to the how we do it, specifically in functional programming. But before that, there is a tool for doing what we were doing, but in a more formal and structured way. A tool for reasoning about structure and essence. And that tool is category theory. Hooray!
Not DDD.
Actually, DDD, and this probably opens a whole other discussion, but DDD is pretty words probably to do a category design. So category theory, I would say it's a proper way of talking about DDD.
Yeah, because you could take these slides, change some words, and it would be exactly the same as DDD.
And that is really.
It's more about putting that in the context of business analysis.
Well, but actually, the world, and because the domain doesn't need to be in a business per se.
Actually,
yeah.
It was born because of that.
Yeah, sure. Yeah.
But actually, that is a really good comment, because I agree, a domain doesn't have to be a business itself. And what I want to say actually is that DDD is just business lingo for actually category theory. And so,
how does category theory relate to set theory? That is what you explained there.
yeah, category theory is more general. Category theory can explain set theory, but set theory, even though it is very general, doesn't necessarily explain all mathematics. So you can, and we can talk that in a moment, actually.
And how does object-oriented relates to category?
Oh, those are really nice questions. But I'm going to start talking a lot, and I want to keep myself. But those are really nice questions that probably we could use a whole workshop just for that. But probably you'll get some insights in a moment. Anyway, I'm going to go to the part 2, because probably we're taking, yeah. So, in functional programming, or at least in typed functional programming, I will say there are 2 main techniques for doing object dependency and functional dependency. The object dependency, it can really easily done just with functions, but it can also be done with the reader monad, and we'll see, or the reader functor that we're actually going to see today. And you'll know what the reader functor is in the end of today. And the functional dependency can actually be done easily through type classes, and even heavily extended through the concept of tackless final, which actually tackless final can be directly a tool to apply DDD. But today, sadly enough, we only have time to see one of them, and we're going to see the reader monad. And probably tackless final, I've done some sessions in the past. In the future, I'm pretty sure we can do one related to these concepts. But first of all, to go from all abstract nonsense into a little bit more code, I'm gonna make a super fast demo of what we're gonna achieve today. So, yeah. Sorry?
You can finish the Zoom on the window, like
This is
Already?
Yeah.
This is Windows.
Yeah. Is this better?
Okay.
Yeah.
Can you do that on Windows? I haven't used Windows like 15 years. I don't know.
So anyway, I'm gonna code something super fast just to because what we're gonna do next is actually see a lot of diagrams, and we can easily get lost in diagrams. So I want to first show you what it's gonna look like in code, and then go to the diagrams. So we're gonna do exercises in the end. So don't worry if you don't quite follow, because the next slides is all about explaining what I'm gonna do right here. So first of all, we're gonna introduce the concept of a reader monad, right? A reader monad is the abstraction of dependency or just a function, okay? So what we want to do is something like, for example, we'll have a computation. Let's create some really simple computations that have certain dependency, right? Let's say that you're in your business logic every day, and there is some mathematical equation you need to some rating, right? Some business. You need to calculate some money around. And say that you have money process 1, you have some money, right? And then you have something like a rating, right? And then there is some really complex thing you're gonna do here. And then let's say that you have more processes that depend money account that depend and also depend on this rating, right? I need to change this one. Money account 2, money account 1, right? And then you have your final computation, right? That will take some input, right? Let's actually get input. This is gonna return the account, right? And then we can do the final computation with given some rating, right? So probably we want to make some discount or something, so this rating is going to be changing, but the rest of the computation is not. So we probably are going to first get the input, so the account 1, account 2 equals get input. Then we can do something like result is a money process 1 with with account 1 and the rating. This is the first result, and the second result is money process 2 with let's say with the first result, with the second account and the same rating, and we return the result. So let's actually make this like some really simple things. Let's make this one just be multiplied by the rating, and maybe this one we add them first, and then again by the rating, right? And the inputs are gonna be maybe 100 and 50, right? Yeah, okay. Then so probably somewhere in your business logic you're gonna have to compute final computation but with different ratings, right? You get the first user and he has a different price, and you get the second user and get a different price, right? So let's say for user 1 we're gonna give him, let's not call it final, let's call it calculate rating, and then calculate rating, and he has the full price, right? But the user 2 gets a 50% discount. Okay? So this is actually an example of configuration, right? Given certain data, the computation changes or the context changes, right? And we're using pure functions here. And actually, I would say this is what is nice about functional programming. In essence, you can already don't need a fancy dependency injection tool, right? You can only use the concept of a pure function just to pass arguments around, etc. But this is not necessarily that nice, right? Because there are two things coupled here. One is the concept of configuration, and the other one is the concept of your business logic. So with the reader monad, you can actually start decoupling this. A monad has two things, and we'll see what this all means in a moment. But does someone know what are the two functions proper from a monad? Okay, and then let's add map to it since it's also a. So we're gonna have a pure here. Well, pure is actually comes outside. So let's make a companion object and say pure of A, right? It actually requires 2 arguments in here. And let's make the A, and this returns a reader from B. Actually, we're gonna make it the B, okay? And then you can also ask.
So you're writing in Scala.
Yeah.
Yeah. In Scala, if you define a class, it also defines its behavior immediately, not like an interface would.
You can have traits or access classes, but in this case it's a normal class.
Yeah, so you can see this as a normal class, yeah. And this is actually the constructor of the class.
Oh. Yeah. Oh, right. It doesn't describe the.
Well, that's the constructor parameter. The constructor is the body of the.
Well, yeah. Okay, fair enough. Yeah.
Sorry.
Oh, wait, so it's actually a type after run. It's a function.
Yeah. Yeah, exactly. And this is a type. This is a whole type. This is actually the function object.
That's the name is called function 1 from A to B.
Yeah.
Yeah.
So now what we can do is actually do this. Reader from A to B, and we make a function. What is a function from A to B? Well, we can make a function that ignores the input and just returns A. Well, in this case it's B, sorry. Fair enough? Mm-hmm. Then we can have map, and map is also very, very simple. We have Z here, Z, and we have a function that goes from B to C and returns a reader from A all the way to C, right? So this is actually really, really simple because it's only function composition, right? So we can create a new reader that takes an A and first applies it to run and then to F, right? So we apply it to run first, and this gives us a B, and then we can apply it to F, and this gives us a C. Right? Any questions here? We're gonna implement this later.
There is no reference to self-heal here, or this?
It's within a closure, so. So I could do this, but actually it might reference the function, but yeah, you could do this. So.
No, it does not.
No, I think it works, but it's not very idiomatic, I guess.
Yeah.
It should work.
The important thing is that the argument of the constructor is within the closure of the body, so you're good to go. So flat map is really similar, except the only difference is that we get a function that takes a B and returns a reader from A to C, okay? And from there we can create a reader from A to C, okay? Also the implementation is interesting. So we open the reader, which is a function from A. We can then create our B by calling run with A and then applying F, right? And this is gonna give us another reader that has a run, which actually takes A. So we're good to go. Okay? Which this actually allows us to do this. We're actually taking this A and basically throwing it everywhere. Like everyone who needs it, just take it, right? And since we have flat map, now we gain automatic syntax from Scala, and we can actually rewrite our programs like this. So first, we can make a function called ask, okay, from A to B. That sorry, only of A. That gives us a reader from A to A. Okay, and then this might be a really dumb function, but it's actually quite useful because ask is gonna actually gives us the configuration that we're gonna require.
Is that like lift?
Lift normally refers to taking something and lifting it to.
Doesn't have any parameter. Oh, yeah. Sorry.
Yeah, it actually doesn't have any parameter.
No, I imagined it. Okay.
Yeah.
It has type.
Yes. It is fine.
So sorry.
It has type. It's like parameter.
Oh well, yeah. It is a type parameter. That is true. So for example, this function here, what we can do is to start decoupling or configuration or requirement from from our stuff, right? So we can do two things. So the first one is make this an actual monadic thing, and do ask, right? And then ask, we can do a map. And what is this gonna give us? This is actually gonna gives us our rating. And with this we can actually do our computation.
Ask is not a function,
Yeah, actually it's a function without arguments.
so you don't need to actually call it with parentheses, or that's not how Scala works.
Yeah, so if in Scala functions without parentheses, you don't have to put parentheses. Yeah, exactly. I actually
You should put parentheses only if it's unit, right?
you should, yes. So you should put parentheses only if it causes side effects.
Yeah. Unit, yeah.
So
unit.
and yeah, exactly. So
That's a
unit
condition.
is a type signature of side effects.
So how would you be able to pass ask around as a function without calling it?
Actually, it's the same way.
Yeah.
But your parameter will be like a function, so compile will understand it.
Oh, so it gets simply infers everything.
Yeah, exactly. It gets inferred by the compiler. Then, for example, let's leave this one like this, and get inputs can be something. We could make a reader that takes that just leaves this into the reader, right? And then calculate rating can become for comprehension. So this is a get input. Then, for example, the get a let's put this into a comment. This one can return a reader. Okay. Don't worry if you're not following completely, because we're gonna see it in a moment. I just want you to see what is the end product. So we can yield the result too. So we first get the input, and then, for example, money process 1. So that is gonna be the result 1. Money process 1. And this actually no longer requires the rating, because we're passing the configuration to the reader. Actually, I think it will be nicer if we do this. Case class configuration, and then there is a rating. And all of these readers, they return configuration. And then this is a config, and this is a config.rating. And then let's make this one also configuration, and this one configuration. And this one, the configuration gets into the type signature of the returning thing. So we're basically delaying the input, the injection of the configuration. So money process 1 only needs the first money, which is input underscore 1.
You can also write parse input in a tuple immediately. So not use input 1, but use like first second. It will be easier to understand. So
Yeah. Okay.
Is that also called destructuring in Scala?
I think so, or just I think so. Pattern matching, yeah. Is it, if I could do it directly here, but then I will need to implement. I could do it like this, but filter.
Okay, I got it. Okay.
And then rest2, and then this is just to exemplify what if we have a pure function that requires a configuration indirectly. Well, we can get the configuration with ask. And then process 2 gets the result from 1, from a conf2, and the config dot rating.
Where would you just wrote reader ask? Where would you get this reader?
Is this reader is this object, the companion object. So reader dot ask. So this function. We're gonna do this in a moment, and what we end up with is actually with the ability. Maybe let's do this. Add this like an extra here, which is gonna be added to the end. Extra plus extra. Okay. So now, what we have ended up doing. Why?
Because
rest2.
Because with strings, it's the curse of Java.
Yeah.
Rest2 is not what it's expecting.
And then ask.
So if it's anything that doesn't have a parse, it becomes a string.
Okay.
Because when you do anything plus anything,
It's
like,
but it should be overloaded. The problem was that this had to be unequal because money process 2 doesn't return a reader, it returns just a float. So remember that when we have a left arrow in the for comprehension, it actually desugars to flat map to this flat map.
Is that also a convention, or is that something that gets inferred from all of the types?
Yeah, convention. So whenever you have something with a flat map inside, you can do this. So that is a special from Scala. So now what happens is that we can have the calculate rating of user 1 with an extra of 5, right? And then this is gonna return a reader from configuration to float. So we basically delete, and then to get the actual result.
We are not yet executing, we're just still configuring.
Yeah, exactly. We actually, the configuration is gonna be the very last thing that we do. And do user 1. And then since this is a reader is just a function from A to B. So from configuration to our final result. And we can actually do dot run. with our configuration, like, for example, the full fare. Okay, so what we basically achieved here was a complete decoupling from configuration to our business logic. We have some pure functions which are purely business logic, like this one, and some functions that on its type declare a specific requirement, right? An explicit dependency. Okay, so this is what we're gonna end up with, and we're gonna see what all of this flat map and whatever means. Any questions?
Why does it look like IO monad?
Yeah. Well, because it's a monad, right? All monads actually pretty much look alike. And the important thing that we need to know about monads is that they allows us to decouple our business logic from context. And in the case of the IO monad, it decouples side effectful descriptions from our business logic. In the case of the reader monad, it decouples a structural dependency from our business logic. In the case of the option monad, it decouples the possibility of optionality from our business model. Okay, so this is the final thing that we're gonna end up with. Actually, in Haskell, you don't have any tool for dependency injection. They just use the reader monad, right? Or type classes. But yeah. They don't have what?
Constructor parameters.
Yeah, no, but actually, like you mean like these ones, right?
Yeah.
You actually kind of do, because in Haskell what you have is product types, right?
Oh, yeah.
Algebraic data types, and they do have constructor functions. So actually, objects, the difference in Haskell is that behavior and data is very clearly, instead of object-oriented, which they just merged both of them into the concept of a class, right? Yeah. So I could actually take these functions out of reader and just make them receive a reader. The way in which Haskell works is that they just take this function out, and then they receive an extra argument with the reader here, right? Which is, it will have been this reader. So they're actually quite isomorphic.
Why wouldn't you do that here?
Just to make, first of all, to get the nice syntax, right? And the second of all, because this is the argument of Scala, right?
Sure.
Like, it is cool to like merge object-oriented with functional programming, right?
I think generally most libraries are built having functions somewhere, and then you have some syntax import that allows you to use the dot something syntax.
Yeah.
So they use functions, they're a bit more involved, but it's all the syntax.
I would say Scala is unopinionated. It's like, we have everything, right? Do it however you want. Yeah. And then,
it's a mess.
and then it's a mess, yeah.
It is pretty hard for me to get through all this because I'm just getting used to Rust. It simply doesn't hide anything. It's like very clear where something is coming from, and like if you want to have something a bit more manual with a macro that can introduce new syntax, if you want to, but
You should
it's
see Scala macros.
But yeah, that for loop there, that could be a macro because you need to do sugar stuff to flat map.
It's basically a sort of macro.
But it is very nice to see how, especially the last two lines, how that works, because it does remind me a lot to Rust's iterators, where you have a collect function at the end, where there's the configuration only comes from the return value that you want to have on your value, basically, the result of your collect. I think that's the same thing.
You basically have to think about this as closures inside closures.
Yeah.
That's it. Basically, actually it is.
Yeah, it is closure.
Yeah, exactly.
Yeah.
Yeah.
I think with Ammonite you can do sugar, you can see it.
Yeah.
Yeah.
You get the structure.
Actually, you can do it. Just disagree it.
You probably do it even here.
Yeah, it's
You can just print it.
If you want us to do it here, so this get inputs. Oh, sorry.
IntelliJ can do it for you.
Oh, really?
And disagree it, yeah.
How do you do it?
If you click on the lamp,
On the what?
the
Bulb, this one.
Ah.
left.
yeah.
Yeah.
No, click on the 4. Click on the 4 first. Yeah. Now disagree.
Oh wow, I didn't know that.
Wow.
Very useful.
Now try to read.
It's
not useful at all.
But yeah.
Yeah, this,
Yeah.
this is exactly like, mostly like Rust iteration that simply goes to map, flat map.
This is heavily inspired by the
Try to lay out it with control
Right, yeah.
a bit more power.
L.
Well, yeah. I don't know.
You can lay out it, right? With the control alt L.
Let me see if.
I don't think it's useful.
Yeah. Well, it is a
But
man.
anyway, it's the same. I think in the Coursera functional programming, they have the same tricks. They just explain like map,
Yeah.
and then you just write it, and then you change this in for comprehension, and just
Yeah.
understand the concept, why it's like it's more easy to read. That's it.
Yeah,
That's it.
exactly.
Only, but yeah, under the hood, it's like concept of map and flat map.
And actually, it's nice because it becomes like imperative programming, right? It looks like imperative programming actually, but it is not really. And this is why we say that, for example, expressions which are like our last program, we actually could say it's within a monad as well, the identity monads, right? But yeah, so let's see actually, because I want to make a relationship between our abstract nonsense with our code that we're doing here, because what we say here that reader is a monad. First of all, reader is a functor. Why? Because it is context that you can map inside. So if you see reader grabs something, and that thing, given a pure function, we can apply it to the thing that it's being grabbed, right? And then flat map is the same thing, except that it ends up combining this reader with this reader. So flat map is only combination of this thing. So a monad is just combination of functors. So that's why we say that a functor is just, no, a monad is just a monoid in the category of random functors. But that's going a little bit more deep. Anyway, that is what we want to achieve. And I want to map it into, so I want to map our abstract nonsense to this by talking about super fast about what actually a category is. So in category theory, we have things. We're very, very objects. Let's not use things, objects.
Or domains.
Or domains, yeah. Or actually we can talk about the category being the whole domain. And we have morphisms, which can be functions, right? Like, for example, we have a function from A to B, a function from B to C, and we have the notion of composition. So if it exists a morphism from A to B and from B to C, then there is a morphism all the way, which we call the composition. There is for every single element, there is an identity, which is a morphism which just points to itself. And function composition is associative, right? So it is, if we have an extra third function here, it is the same to first compose the first two and then with the third one, that composing the last two and then with the first one. Now, there's a lot of categories. The most important category probably for us is our programming language. Our programming language makes a category with our types and our functions. You can actually, this is more generic than set theory, for example, because you can make categories which morphisms are not functions and objects are not types. Like, for example, proofs, right? Where objects are truths and morphisms are implication, right, etc. But the most important category for us is the category of our programming language, where the objects are types and the morphisms are functions. And there is composition, there's identity function, etc. Right? So, when we create a functor or a monad, or in this case, when we're abstracting a little bit, what we want to do is actually create our category, okay? Or if we're doing actually domain-driven development, what we want to do is create our own category, which is a little bit more restricted. In this case, we're gonna make the category of dependency injection, okay? Where objects all depend on certain dependency D. Right? We say the essence of dependency is a function, right? So all objects in this category, they all depend on D. Then we need to add our functions between all of these objects and our identity function in all of these objects. And then you're asking, why are you putting an R there? It is because we're gonna give the concept of a functor. And this is what we're doing in our programming language when we do map. Map, it comes from the functor, which a functor is a mapping between categories. In the same way in which a function is a mapping between types, a functor is a mapping between categories. And mapping means that for every element, for every object in this category, we map it or relate it to an object in this other category. In this case, we're going to have our category of our programming language when we have, for example, integers. And the corresponding object in our dependency injection category is an integer that depends on D, right? And we have string, and the corresponding object is a string that depends on D, right? And the functions between them, so when we do in our programming language .map, what we're doing is actually mapping this function, this pure function from A to B, to a function that is able to map elements between A and B. And when we do flat map, is actually we're doing the process and making an extra smash in the end, right? An extra combination in the end. And the most important thing about functors is that they preserve structure, which means that it is the same to first compose. So GOF is the composition of these two. First compose and then map. Then first mapping to F, then mapping G, and then composing them together again. Okay? So that's what it means to preserve structure. So the advantages that we get from going through this process is actually that first we decouple our business logic. So why? Because we want to keep all of our pure functions only from A to B, only from integer to string as much as possible, and decoupling them from context. In this case, the notion of dependency. Also, all of these can be independent composable parts, like we did in our small example, right? They were independent functions. They all declare dependency, etc. But we could compose them in the end with flat map, with map. And the nice thing is that we can compose first and in the right moment do our injection, right? This is what we did in our code. We first did all of our composition of all of our business logic and dependency injection, how dependency injection or dependencies will play. And then in the very end, we actually provided the dependencies. And the nice thing is that the context or the effect becomes part of the type signature, which is really nice because then you can reason about, right? Oh, this function is returning a reader of configuration and integer. Then I already know that what I'm getting back is something that still requires certain configuration, right? So it becomes, the functions, they talk to you, right? So So actually the next part is actually making the exercises, and we're actually gonna implement this from zero. But what I meant with that last statement is that, for example, what if I remove this, right? And what if I remove this? Which of the two functions actually talk to you more, given just the type signature? The second one is actually just saying, hey, I received these things, whatever they are, and return you a float. But the second one is talking to you, is saying, hey, give me these things, and in the end, I'm gonna give you something that has still dependencies, right? So this is a nice thing about using monads, that type signatures become very expressive, right? The context becomes part of the type signature. So, if we're gonna, the most important thing in the end is actually code. So let's actually get started. So let's first code the reader monad with the map function, right? So what is the first part? Well, the first part is creating the context, right? So we're gonna call it reader from A to B, right? So let's actually write it here. When we're using our beautiful monadic design pattern, the first thing is to declare context, which is this. Then the second step would be to declare declare what is being wrapped by the context. So in this case, it is our notion of dependency, right? So we put it in the constructor from run from A to B. I'm gonna comment all of this because it's making naming clashes. Right? The third step is to make our ability to map a pure function and apply it to our context, right? So third is map a pure function and apply it within our context. Okay? How do we do it? Well, with the so famous map function, right? In this case, we could change reader and to make it more cognitive, easier to think about. We could change A and call it or D, or even so much there to call it dependency. We can also do that. If you like, you can name it however you want. Second one is, the third step, map. So this is our pure function, right? So f is a pure function from A to B, right? This is a function that was in our programming language category, the one that didn't have any context. And then we return something within our new category, the dependency. So it still depends on dependency, but in this case it returns a B, no longer an A. In this moment, the steps are really simple because first we know that we need to return a reader, right? So we start by building the reader. Then we can add the type signature, which we already know again. And we need to put the thing that is being wrapped. So in this case, the function, right? this run function. So run is a function from dependency to 8, right? So in Scala we have the nice lambdas, so we can have a function that goes from A, and then it needs to go to B. So actually there is only one implementation of this, right? So if I already have an A and then I need a B, and I already have an F that does that, so I only apply it here, right? Oh, sorry, this is the dependency. Sorry, this is not A, this is dependency.
Dependency to A and then A to B.
Yeah.
You should run and then F
Yeah.
on top of run.
Run with the dependency. Sorry, yeah. And then F, okay. Yeah, exactly. So first we have, sorry. First we have a function that given a dependency gives us an A, and then we have a function from A to B, so we can just compose them. Actually, this can easily be interchanged to F compose run. Yeah. So now, as a first exercise, I will dare you to delete what you just did and do it from 0. Like re-implement it.
I'm still trying to get my type right. So the map should return a reader with a dependency. Yeah. This should be the signature, right? Where the map would take something of a dependency type A.
If you have any issue, I can help you directly, or you can pair program as well.
So basically, this would be the dependency, which so this is a type signature basically, where T is generic and B is generic. T should be the input.
So do you want us to work this one together?
Okay.
Do you have a Scala environment?
Reader type where A and B
Scala
are
Fidel?
Yeah, that's fine.
But I have somewhere.
Or you can come and sit here,
Oh, okay.
and we'll do it together.
Yeah.
So I have no Wi-Fi. I have no Wi-Fi, so I tried to.
Trying to, yes.
Oh yeah, we need to put the Wi-Fi
So this
somewhere.
one is
So the first step is to
have a
declare
context.
context, right?
And then,
So let's write case class reader. Okay. Sorry, I need to. Yeah. Okay. Go.
I typed very badly. So reader. This is the A.
So in Scala.
Reader.
Good. Now in Scala we need to make it this a class, or in this case a case class, just for convenience. Or
Class.
yeah. And just for convention, we need to make the first R capital, right? It needs to be camel case.
Something like that? No, not necessary. So capital.
So
Oh, the R.
yeah. So capital locks are here. So this is creating a class, right?
Alright.
Then in Scala with brackets, we can have some type arguments
Okay.
right?
Yeah.
In this case, we're gonna call it D for dependency. So big D,
D space
and then comma,
this.
yeah, and then we're gonna the next one call it an A.
This should then be also.
Yeah,
Apply.
okay, because we're gonna use those for the constructor here. So if you open a parenthesis to make the constructor of the class and make it there, we can put a function there, or in this case we're gonna call it run, and then you do colons to do, this is the type of run, so like the 2 dots.
Like what? Which one?
Oh, none of them, so just type shift
Okay.
and then colon, and what we're basically saying is that this is gonna be the type of run, and run is gonna be a function from D to A. So in Scala we do it by saying D and then arrow, like fat arrow, and then a fat arrow is equals, and then a greater than,
Where did they leave A?
yeah, and then A.
So we have
Oh.
math.
Or capital A. No?
Yeah. No, the convention will be to make D and A capitals.
Oh.
Oh yeah, sure.
Good, awesome. Now, this is the context. This is our abstraction, right? This is what
This is the context.
Yeah, exactly. So we're saying basically there exists a function that is basically an A that still cannot exist. It will only exist until we provide a D.
Yes, the context.
Yeah, exactly. And now what we want to do is to be able to convert this A into a B without having to lose the abstraction, okay? And we're gonna do it by making a function in the body of the class.
In the body, here.
Yeah, so you just open braces.
The same sentence.
Yeah. Yeah, exactly. And enter. Oh, these are parentheses. We need this one. So shift.
Brackets.
Yeah, these ones. Yeah. So this is the body of the class.
Yes.
And here we're gonna make a method called with def. Yeah. And then we're gonna call this method map.
Oh, basically it's like going to implement
Good.
some,
And the convention is that this to be lower capital. So not lower capital, just a lower. Yeah, exactly.
do I need access
Small.
to run in
Small letter. Yeah.
Yeah. So here we first need a type argument because we want to transform this A into something
B.
else, into B.
Yeah.
So we need to add another argument here, which is gonna be big B.
B.
Mm-hmm. Yep.
Oh no, sorry. Yeah.
And then let's make it capital.
Capital.
And then let's make the argument of the method. So with parentheses. And the argument is gonna be a function, right? We'll just call it f. And f is gonna be a function like this one, but it's gonna be from A to B,
Okay.
right? So we're basically providing the ability to transform any A into some B.
yeah, this is setting this is constructing reader with
No. You mean like this?
here.
Yeah, exactly.
No, but do I have to sort of
But self
Yeah,
is
and then it's gonna return.
instance of reader.
Then
And then return the same
yeah,
sentence,
exactly.
same rule, return.
No, in Scala, the return type it's with another colon, so it's here, and then put the type there. So we're gonna return a reader with capital R.
Compose is a keyword.
No, it's a function. It's like algorithm. You apply the same one.
And then this reader requires arguments like this one, right?
Okay.
So it is gonna return a reader from D, so big D, comma, but instead of returning it, instead of saying a reader from D to A,
To be.
it's gonna be to B, exactly.
Actually, be recursion.
And then we add an equals to start the body of the function.
I don't know how. I don't have internet, so.
It's with this one. Yeah. And then let's go to the next line.
Like, do you have function as values in?
Yeah.
So how do you
So-
compose the function?
So we're saying we're gonna return a reader, right? And this class is already the reader. So we say new reader to create the object.
Let's say we have a function from the string to
And the constructor is this. The constructor requires a function from D to A, right? But we're creating a reader from D to B. So let's open parentheses to start the constructor. And then in its, yeah, parentheses like this one. Yeah, normal parentheses.
Oh, normal.
Yeah, this is the constructor of the object, right?
Now it says from DB.
Yeah, exactly. So we need to provide it. In Scala we have lambda functions, right? Which are functions that, or like methods that are nameless. They're anonymous. So we do it by let's provide.
Yeah, there's something. Yeah, but
So-
for example, for a vector.
Not this.
We have a Wi-Fi.
No, listen. Yes, we do.
It's,
Yeah, but well, this is your other phone. I could do.
Access net 1.11.17.
That wouldn't be fair.
Yeah, Darwin get lost in these. So read the A to B and capital A, capital N.
Yeah.
B is then 7, right?
No, sorry.
A dependency.
Yeah, A is the context and B is the.
So here, Giovanni, it's
dependency to B and then.
So the way in which we do it in Scala lambda function is first we put the argument. So instead of we do it like this. So let's call it D, but with lower D because now it's not the type, it's the value.
You mean like this?
You're like, whatever.
No, it is more like, let me show you. I'll do it down here first to show you. So when we say like, let's say for example, full, we say it's a function from let's say integer to string, right? And the way in which we can create a function from integer to string is by making a lambda, by saying, hey, this is a function which takes an integer, which is an integer, and then we make a fat arrow like the type, and then we use this, maybe this integer and this integer dot to string, for example, right? And this is returning a string, so this is already a function from integer to string. You see? So now we need to do the same here.
You mean to string?
No, we need a function that goes from D to A. So
to
let's,
A.
so instead of integer int, we need a D. So let's do lower cap D, and then colon, and then big D, big D, so pam, and then fat arrow,
Because they say that you have to
to A to B and then
This was
Something like this.
Yeah.
2017.
Oh, yeah, sorry.
Yeah, space.
The only time I looked
And now, probably we need to put this into parentheses as well,
But I always
from
wanted
A to B.
like this.
So I have done one.
And then we need to transform this D
Like context
into a B.
points in the middle.
Now let's think, do we have the tools to do that?
Do we need another? No, it's okay.
Really helpful name and understanding.
Yeah,
Then we go to B.
So we already have a D, right? And we have a function that already creates us an A, and we have a function that creates an
To a B.
to a B, and that is the thing that we need. So let's do that. Let's first call run with D.
Context and here apply context and then automatically just those two functions.
Well, it's a function, right? So you can open parentheses and then pass the D inside, right? Oh, so the small, yeah. And then this already created an A. So now we can apply F with, yeah, press shift, boom. And we close parentheses, boom. And it's done. We create a reader that will take a D, right? And it's gonna pass it first to run,
Right.
and then to F, and it's gonna create the reader, right?
Language like
Okay?
you could
To a B.
Yeah,
do it programmatically.
exactly. And now
You have one way to build it, bro.
the thing that we can use it for, let me show you. So,
registers and then you
So this is Scala.
yeah, this is Scala. What is your normal programming language?
Yeah, I used to be a Pascal programmer.
Oh, okay.
I used to work with Ion the Ashidra in the expert system.
Oh, okay.
Tool.
I
It's a
see.
tool for an expert, for making expert systems.
Oh, okay, interesting. So now what we can do is have a function, for example.
I used to work with the Power Builder. You know,
No.
one of the, let's say, fourth generation tools.
Ah, okay. Oh, wow. Now, for example, if you have a function, right, that maybe, or example, let's say you're calculating the rating, right, a price for a user, right? And then let's imagine we have a function, right, so get price, that let's first create the concept of a user, right? A user has its base price, right? Let's make it a double. So when we want to get a price, maybe we give it a user and we give it a rating, right? And we get the final rating, right? And we can easily use it by saying get the user base price,
I'm really interested in what
and then multiply it by the rate.
bringing in
Right.
linear types.
So that is very simple, right? So for example, let's get the response one might be get price of a user. Let's create a user one. She's a user with base price of 10 euros, right? And then get price might take the user one and a discount of 50%. And this is gonna gives us the final price, right? Which is gonna be the 50% of 10. Now, what we want to do is use our new reader abstraction to decouple rating, which is a configuration that we're providing, from this computation, which is our business logic.
Okay.
But this is a B.
So
returns a
what we can do
Context
B.
is
So yeah, just to
make get price
out of the F
and move the
just call
configuration
run again,
from the
that's
function
a reader.
into the type
And you
signature
apply
by
the
saying
context on
this
C.
is a reader
Yeah.
that takes, let's
And
make
so
rating.
Yeah.
Someone, does anyone want anything?
No.
Thank you.
Something else. I want this one.
Oh, this one I bought from somewhere else.
Oh,
But I can
okay.
give you a sip if you
No,
want.
no, 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 no. Something else.
How do you know that this context has run?
It hasn't.
Context doesn't have run. The reader has run.
Yeah, exactly.
And why reader has run? Where? Oh, this one.
Because this class
Oh,
property is a
the
function.
properties function.
Yeah.
Woo! Nice. Okay, yes, I got it.
Oh,
The
there's no power.
It's rather similar to that.
okay. If you're done, you could implement flat map, right? Which is flat map. It's very similar, but it goes from A and instead of to B to a reader of B. Right? And then actually just try to implement it. There is only one way to implement it. Actually, there is a proof that these monadic, if you use pure functions, these flat maps, there is always only one implementation of them.
Yeah, for any
Under certain contexts, I need to remember, but yeah. Like all of these, they always have. So you only need to follow the types and
Yeah.
try to. But anyway, going back to you.
Okay.
We're gonna make a reader that receives a rating, okay? And given a rating, it calculates the final price, okay? Now to do that, we need a new function that creates a reader from nowhere, and that function we're gonna call it ask. And ask, it's gonna ask for your dependency,
As an input.
and actually only the type. So it's still not asking for the actual dependency. It's only saying, hey, what is gonna be the dependency you're gonna need?
Okay.
And then we say
It's a parameter.
as a parameter, yeah. This is actually of type, so we're gonna call it D. And this is gonna be a really interesting reader because it's gonna be a reader that takes the dependencies and returns the dependencies. Okay?
Okay.
And that's really easily implementable because we can say new reader and we take the dependency and just return it.
Okay, the same thing.
Yeah. So now what we can do is say,
It's not a syntax for
we can say ask and pass the thing that we want to ask. We want to ask the rating. And now we can use our function that we did, map. And this is gonna map, it's gonna record a function from A to B. And A, in this case, is a rating. So now we can actually do our computation, user.basePrice times the rating. And this is gonna return the final price. So rating.rate, because it's inside the case. So rating.rate. And that is nice because we're doing all of our business logic without needing to inject the rating. So we can do, for example, get price.
So this rating, this parameter, the value of this parameter,
Yeah.
he gets from this one.
Yes, exactly.
Oh, okay.
Exactly. So now So now we have the response 1. So get price of the first user returns a reader from rating to double, right? Sorry, reader from rating to double.
So reader from dependency.
Right?
You should probably call it big.
So now you can actually. So this is actually a nice example because now we can say price 1 can be the response 1, and then we do dot run to run this actual function that requires a rating, and it's gonna give us the price. So we can run with rating 0.5 or get this another price.
There is.
With a different rating.
So we have to construct a reader then.
Yep.
That has a run field.
Yep.
That takes a closure in this case.
Oh, sorry. We need to this in order to access run. We need to make it a case class. But yeah, I'm done. So we first composed all of our programs. So because this can get really complex, we can compose more and more using map and flat map, and then leave providing the configuration, which is the rating, all the way to the end. And now we can calculate different prices with different ratings.
Okay.
And that is the beauty of using this abstraction, which we call the reader function or the reader moment.
There are some fake things for me because I don't know what flat map is.
Yeah, yeah. This one, don't worry about it, because this was just an exercise. But map, it's only the function that we use in order to bring a function from the outside and apply it to our context. So we're taking a function from
outside, yes,
and applying it to our context.
And our context is D.
Yeah, and our context is D.
And the function is reader. In our case, or the F.
F, exactly. The function is F, exactly. So for example, when we got the price, so for example, first ask is a reader that takes our context and delivers to it, right? It delivers the context.
Yes.
So when we do get price, we first go and ask for the rating, and we can call map, and maps take a function from the outside world, right?
Okay.
So we can actually put this function and make it name here. Business logic, right? Business logic is going to be a function from a rating.
It's not an input yet. Correct.
Okay.
Can you call it something else?
Is that the same as imply or not? No.
It can be isomorphic, but it doesn't. In
So
this case,
how do you call it again? This sign?
this is the sign of a function. This is creating a function.
Oh, okay.
Just like this, but the difference is that this doesn't have a name and this one has a name. So the nice thing about making a function like this is that you can make it inline in the argument, because map has one argument and that argument is a function. So we're creating the function on the go.
So you make it more explicit in this way, or?
Yeah, more explicit, and you can, if you need a function in that moment, you can make it on the go and just.
Okay, so you can make it on the go. Yeah.
Inline, yeah.
Dynamically. So
yeah, exactly. In this case, it's a function dynamically done that uses the user base price to calculate the final price.
And about the F here, how does the program know that it is from outside?
Because it's an argument. It's just a normal function argument.
So every argument comes from outside in this.
Yes, exactly. So
or in mapping.
Yeah. So for example, this type A to B is as good as saying this is an integer. In Scala, function types are the same as normal types.
I can't pass self as well.
So yeah, this type is as good as this one.
And you say A to B.
Yeah, A to B. It's a function from A to B. So here's a small example that we did, in which first we composed our whole program, getPrice, right? And getPrice, it takes a user base price and multiplies it by the rating from the context, from the configuration. So the nice thing is that we could do getPrice for user 1, and then with run, we injected different context, we injected different ratings, and generated different price. So we say, hey, this is your price with 50% discount, this is your price with 80% discount, and maybe this is your price with full price, right? So, and that's the nice thing that we get from completely decoupling context from our business logic problem. Were you guys able to implement flat map? Good. Now, can you implement? I'm gonna hide it. Can you implement ask?
Yeah, it's already there. And ask should be outside, right?
Yeah. Companion object, or just outside, yeah. And if you already implemented ask, flat map, and map, then try to use it, right?
There's another one that I find useful is it's called local or something like that in Scala Z cuts.
Yeah.
So giving a reader from A to B gives you a reader from a broader context to B, giving a function from that broader context to the smaller one.
Yeah. So we can actually start to implement those nice functions, right? For example, you could implement local. Actually. Let's
Val is value. Huh?
Val is value, yeah. So if we go maybe.
Which Wi-Fi is?
Let's go to cats, just because I know the source code very well.
Yes, Wi-Fi.
Actually, I can. Yes. These guys have it. Giovanni has it. The Wi-Fi.
Yes, I already forgot the.
No.
Def is from definition.
Access net. Alright.
Yes, to define a new function, exactly. Yeah.
Capital A, capital N, access net, 11.
Okay, thanks.
And it's validation. Who's a Lambda as a Wi-Fi gap?
I hope that at least
Case is from the same as if.
So case
is not the same case as in Java and Pascal.
Case in this case is making a class that has this as a value. So so makes it part of the attributes of the class, and also makes it so that you can do, instead of new user 1,
it's a short
yeah. So if you add case, you don't need to put new here, you can omit it, and you can also omit this one.
Okay, so short
yeah, it's
writing,
sugar.
short writing.
Yeah, exactly. It's just sugar code. Just to making a class so that for example
sugar code means wrap.
Sugar code means that they add some syntax.
Yeah, okay.
That they will.
So it's a package in itself.
Yeah, exactly. So for example, here we can remove new from reader because reader we made it a case class.
Yeah, it's a function. Right?
But that's it. It's just convenience, you know. It's just nice to have.
So right now I'm just running into
the size of a function.
Do you guys were able to implement flat map?
Again, now I still a bit confused how to combine two readers, for example.
Okay. So, okay, let's do it together, and then you can repeat it, right? So actually, you just need to follow the types. So first, it says it's gonna return a reader, right? So, bam, we create a reader. Then the reader needs to be a function from D to B, right? Okay, let's ask for a D and create a function. So let's follow it, right? Let's first, well, we need the A, and we already have a function that provides that A for us. So let's create it from the D. And this returns a reader, right? And this is probably where you're stuck.
No. I cannot find flat map. I don't know how to use it after implementation, because this looks like a bit useful, because I can create two functions. Both of them will return reader, and then I can combine them. For example, first is typed for whatever and int as a result, and second type as int and whatever. And how I can use result of first reader as input for other reader.
Oh, well, you just...
With different first type, different dependency.
Now there's a bunch of nice combinators.
So because you said whatever and reader whatever.
Yeah. So let's...
So the dependency is different. You have a reader from A to B and a reader from C to D.
So let's...
No. Now you're using 4 different types.
Okay. Dennis, let's actually do it. So for example, let's double the price. Double the price, right? And this is gonna return the price, which is a reader from rating to double, right? And return a reader from rating to double, right? So price is a function, so we can use it several times, right? So let's actually make it within for comprehension. This is gonna use flat map. So let's get price 1. This is probably not the best way, because I mean you can just do times 2, but let's not do that. Let's do price 2, price, and then yield price 1 plus price 2, right?
No.
And it's done. So for example, this response 1, which got the price for user 1, I can say doubled. So reader from rating to double, and say a double price of response 1. So for example, if I say val price 1 doubled, say response doubled dot run with the same rating 0.5. So price 1 is gonna be what? Price 1 is gonna be 5, and price 2 is gonna be what? 10. I'm gonna put it like this. You see?
Yeah, but I mean because stuff.
Shouldn't it just be price dot map and
But times 2?
Yeah.
Yeah, exactly. Let's yes, that is true. But okay, let's make an example that actually. So let's.
I think you wanted to see how to use the result of
prices?
the first one to.
So these
Yeah,
So
but,
this-
I got. So you shouldn't just use it in a.
This is called flat map. So
Oh.
this allows us. So this flat map,
Yeah.
Scala makes sure that if you have something that has flat map,
Yeah.
it allows you to use this syntax.
still the same thing.
And as you can see, it becomes nicer to read and etc.
I expect something that implements this.
Yeah. Maybe Clojure implement spend. Maybe. No.
Oh.
It should be. It's more interesting case. Yes.
Yeah, okay. And then you're basically taking two independent programs and combining them together.
That's an applicative.
Yeah, you could use an applicative so you don't have to flat map. But yeah, you could use the applicative up to for this case. So if yeah. But the important thing with flat map is that allows you to do for comprehension, right? And then your programs, they just become like boop, 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 boop. Independent programs, they compose together. That's the most important thing in functional programming. You achieve complete independence of each parts.
Which independent programs do you mean here in this example?
For example, price 1 and price 2 are independent parts, right? And then we're combining them here.
Yeah, P1 is a program.
P1 is the results of price 1.
Yeah.
So it's gonna give this double, it's gonna end up in P1, and this double is gonna end up in P2. We're gonna add them, and it's gonna end up in this double.
So these are two independent programs.
Yeah, exactly. And the nice thing is that we're delaying providing the dependencies all the way to the end.
Execution, right?
Yeah.
Okay, so
So if you guys want a little bit more material, so checking the source code of CATS or Scala sets probably is not the best thing because they generalize even more. But you could give it a try. Like for example, reader, there's actually a more general thing called the reader T, which is actually called Kleisli.
Reader T?
Yeah, so reader T is also called Kleisli. It's something that has the extra argument of returning an A within an effect.
From I32 to I32.
And this actually generalizes monad because run actually, as you can see, it looks like something that you will put into flat map. Huh? Let's actually make it there. And
focusing on something. Expect factor on anything. It's a field.
So you can.
No method name run found for.
sorry, it's a function from A to f of b, and reader actually becomes just a type alias of reader T with the identity monad. The identity monad is the monad that does absolutely nothing. It has the context is nothing. There is no context. So it goes more general.
It's dummy.
Yes, exactly. So when the identity monad is something like actually the identity monad is like this. It's basically A without context. It's the same.
You can call it like
so
you talked about delay, you said.
Yeah.
So can you explain me again where are the delays? Where can you see it?
So the delay is that we're doing all of our computations without still providing the rating. We're delaying providing the rating to the very end.
So we use rating all the time without giving it a value.
Yeah, exactly.
Okay.
And this is
in the end, then a value turns out.
Yeah, exactly. And that is the delaying part. Exactly. Cool, right? So this means you can make your whole computation and then just run it with different parameters.
So Scala is typical because of the fact that you count with abstractions that has no value in the beginning, but
that is the composition of
You will get the value in the end.
Yes, exactly.
with this function.
So, well, at least the functional programming styles, right? In, for example, Haskell is another programming language which really sticks to functional programming. But what we mostly try to do is decoupling. So, separate the concept of some effect like dependency from your business logic. So that providing the context is different from doing the composition of your programs.
No, you could just create a rating.
I'm not very sure.
So instead of aspirating the
For instance, business logic. What do you mean exactly by that?
Well, doing something like, for example, calculating the final price, right? Or adding prices.
Yes. Okay. So there are some normal things that you could do manually.
Yeah.
That is business logic.
Yeah.
Let's say.
Yeah.
And the other part, what did you say?
Is the coupling from the context, right? In this case, the context is that rating is configuration.
All you need to do is
It's something that you don't need to have right now.
Okay. Configuration. And that is decoupled. Configuration is decoupled from business logic. That's what you said.
Exactly.
Yeah, I got it. Okay.
Yeah.
This one and this here is applied to my. Can you tell them? Can you give the head parameter of D?
Yeah, I can.
All right.
Give me a few minutes.
Okay, guys, we're 20 minutes over the time, but sorry. As usual, yeah. So I hope you guys it was useful for you guys, the discussion and the coding and the examples, etc. And for everyone who was new, thank you for coming. And this is basically what we do. What I'm trying to do is pass this knowledge of being more general and using maths and getting excited about this abstract nonsense. And hopefully it's going to be useful for your day-to-day life and work or fun projects. And thank you for coming.
I really have a feeling that if we would call it at some